Hello, ma'am. So today we will be discussing about the derivatives of trigonometric functions, inverse trigonometric functions, and implicit differentiation. So first, we will give examples for the derivatives of trigonometric functions. So for example number 1, we have here y is equals to tan times sine 4x. So how do we get the y prime for this? So first of all, we need to get the derivative of the first term, which is the derivative of tangent. That would be secant squared. And the angle for tangent is sine 4x. So we just need to input sine 4x as the angle for secant squared. And the derivative for sine is cosine. The angle for sine will be 4x. So we just put 4x here after cosine. Cosine is 4x. And the derivative of 4x is 4. So basically, we just got the derivative of each term. For tangent, the derivative of tangent, for the derivative of sine, and for the derivative of 4x. So all in all, that would be equal to 4 cosine times 4x secant squared sine 4x. For our second example, we have here y is equals to sine squared 3x. So how do we get this? So first, we need to square sine and 3x. So you put it like this. So y is equals to sine 3x squared. And to solve this, we need to this is for the power rule. We need to transfer the 2 in the front, then subtract 1 from the exponent. So that would be 2 sine 3x raised to exponent 1, and finding the derivative of sine would be cosine. The angle for sine would be 3x, and the derivative of 3x would be 3. So simplifying all of this would be multiply 2 and 3, that would be 6 sine 3x and cosine 3x. So going back, we have another discussion here. So this discussion will be for the inverse trigonometric functions. So we have a given here the derivative of arctangent square root of x. So the formula for arctangent would be u prime all over 1 plus u squared. So our u here would be square root of x, or simply x raised to 1/2. And our u prime would be 1 as a square root of x. The derivative of the square root of x, or the u prime, the prime of square root of x, would be 1 all over 2 square root of x. So we need to input here using the formula. The formula says that u prime, so our u prime is 1 over 2 square root of x all over 1 plus u squared square root of x squared. So that will be equal to 1 all over 2 square root of x over 1 plus x, because the square root of x raised to 2 would just be x. So in order for us to get rid of the fraction in the numerator, we must divide both sides by the term here, which is 2 square root of x. So we divide the numerator and the denominator by 2 square root of x. So the 2 square root of x in the numerator will be cancelled out. So that would be equal to 1. Because 2 square root of x is cancelled out, there's only 1 remaining. 1 all over 1 plus x times 2 square root of x. So for us to rationalize this expression, we need to divide the numerator and the denominator by the square root of x. So 1 times the square root of x would just be simply be the square root of x, and the square root of x times the square root of x would only be x, so that would just be 2x. So that would be equal to square root of x all over 1 plus x, and the square root of x times the square root of x would be just x, 2x. That would be equal to that would be equal to square root of x all over 2x times 1 plus x. So for example number 2 on the inverse trigonometric functions, we have here the given the derivative of r cosine times 5x minus 9. So the formula for our r cosine would be negative u prime all over the square root of 1 minus u squared. So our u would be 5x minus 9 and our u prime would be equals to 5. So y 5. Because 9 is a constant, that will be automatically 0, and the derivative of 5x is just 5. So we're gonna input this here. We're gonna input this here as our formula, the negative u prime. So our 5 would be negative 5 because that's our u prime all over square root of 1 minus u 5x minus 9 squared. So squared. So this is our final answer for the r cosine inverse trigonometric function. So hello ma'am, for our last topic we'll be discussing about implicit differentiation. So we are given here the x squared plus 2xy plus y squared is equals to 5. So for us to solve this, we need first to get each term's derivative. The derivative of x squared would be 2x, and for 2xy we're gonna use the product rule, which is get the derivative of the other term and copy the other term, and plus the copy the other term and get the derivative of another term. So I will explain it here. So here we have the derivative of xy would be 2x, and the derivative of 2xy would be, first we need to get the derivative of 2x, the first term. So that the derivative of 2x would just be 2, and we're just gonna copy y. Then plus, we're gonna copy 2x because we already got its derivative here. And we're gonna get the derivative of y, which is 1. And every time we derive y, we need to input a dy all over dx. Plus, the derivative of y squared would be 2y, and we derive another y, so we need to put another dy over dx. And the derivative of 5, the derivative of 5 would be 0. So proceeding, we have here, we need to, all the dy dx terms, we need to put them out front and transfer all the other terms to the other side. So that would be equal to 2x dy over dx plus 2y dy over dx equals, our 2x here would become negative 2x, and our 2 times y here would become negative 2y. So here we can see that we can cancel all the we can divide them all the terms by 2. So we're gonna input the 2's here. So we're gonna cancel all of the 2's here because we divide them by its own self. So dy over dx would be x. We have here remaining x on the first term, x plus and y equals to negative x and negative y. So in order for us to derive dy over dx, we need to divide the both sides by the dy over dx value. So that will be x plus y. So proceeding, equals dy over dx. So x plus y all over x plus y. Here we're gonna factor negative 1, so this will become x plus y. The negative sign will disappear all over x plus y for us to cancel it. So we cancel all the x plus y terms, and what remains is negative 1. So that will be dy all over dx would be equals to negative 1. So for example number 2 in implicit differentiation is, we are given here 5x minus y cubed is equals to 8. So as I've said, we can use the product rule every time we see this type of term. So we need first to get the derivative of 5x. That would be 5 times the y. We just copy the y plus the first term. We copy the first term, which is the 5x, and the derivative of y would be 1. And as I've said, every time you derive a y value, you should put a dy over dx after it. So minus the derivative of y cubed would be 3y squared, and because it's a y, we'll input again dy over dx. That's the rule of the implicit differentiation. Equals to 8 is a constant, so that would be 0. So moving on, we will transfer all the dy over dx values out front. So this would be equal to 5x dy over dx minus 3y squared dy over dx. This equals to the 5y here, because it's not a value of dy over dx or y, we're gonna transfer it here to the other side, so its sign will change. That would be negative 5y. So if it was negative 5y here, its sign will change here to become positive 5y. So proceeding, dy over dx will be equals to 5x minus 3y squared equals to negative 5y. So for us to get rid of the dy over dx, we need to divide both sides by the value of dy over dx, which is 5x minus 3y squared. So we're gonna cancel it out here, and all that remains for dy over dx would be negative 5y all over 5x minus 3y squared. So that would be equal to dy over dx, or dy over dx would be equal to negative 5y all over 5x minus 3y squared.